Welcome all to the discussion on a special problem on Fourier transform. The question is, show that the Fourier transform of f of x is equal to a minus modulus x for modulus x less than a, and f of x has a value 0 for modulus x greater than a greater than 0. The answer to this question is root of 2 by pi 1 minus cos na by n square. And we are also asked to show that integral 0 to infinity sine t by t whole square dt is equal to pi by 2. So some important points to remember while solving this problem is that if the function is taken as modulus x, then f of x has a value x for positive values of x, that is x greater than or equal to 0, and the function will have value minus x for x less than or equal to 0. Now let us write the equation, the Fourier transform equation which we have already studied. We use the standard formula, that is f of n is equal to root of 1 by 2 pi integral minus infinity to plus infinity f of x e raised to minus I n x dx. Here f of x is equal to a minus modulus x, please remember that. So what we are going to do, let's see. For all the values other than x is equal to greater than plus a and x less than minus a, all those values are 0. Only the function will have a value in between minus a to plus a. So the limit, that is minus infinity to plus infinity, limit changes to minus a to plus a. You can see here that it becomes minus a to plus a. Now we have to integrate. Before that, you remember one important point, that the function f of x is equal to, if it is modulus x, it has two values. In positive side the function will have plus x, and in the negative side it will have minus x. So I am dividing the integral into two parts. One integral I am going to do with respect to positive values of x, so I take modulus x as x, and in another integral I am going to take modulus x as minus x. So I have splitted the total integral from minus a to plus a to 0 to a and 0 to minus a. Now let us integrate. So I call the blue integral as I1 and the orange integral as I2. So let us compute I1 and I2 separately. So I1 is equal to integral 0 to a minus x e raised to minus I n x dx. So when you integrate, we will get something like this: a minus x e raised to minus I n x by minus I n plus e raised to minus I n x by minus I n all square. You have to give the limit 0 to a. So this we have used the Leibniz formula of integrating there when there is two functions involved. So I have given all the steps. You can just look into the document which I have shared. So I1 we will get an answer like this, that is minus a by minus in plus a raised to minus ina minus 1 by minus in all square. And similarly you try to solve I2, then I2 we will get the solution as this one: a by minus in minus 1 minus e raised to ina by minus in all square. Now you have to add up these two integrals to get the final integral. So I am adding up. So the first term in both the integrals get cancelled, and the remaining we will get the answer as f of n is equal to root of 2 by pi 1 minus cos na by n square. Now to do the next part, we have to remember the inverse Laplace transform, that is inverse Fourier transform. That is f of x is f 1 by root 2 pi integral minus infinity to plus infinity f of n e raised to I n x dn. So you substitute f of n as 1 minus cos na by n square, and then there is a very important formula that 1 minus cos 2 theta is equal to 2 sine square theta. So in this case 1 minus cos na becomes 2 sine square na by 2. Now the f of x, that is inverse Fourier transform, becomes 2 by pi integral minus infinity to plus infinity. And I have substituted one more thing here, that is I am going to substitute na by 2 as na by 2 as t. Then this integral modifies into a new formula that you can see over there. That is, and if na by 2 is taken as t, then this equation modifies as f of x is equal to a by pi a by pi integral minus infinity to plus infinity sine t by t whole square e raised to I into 2tx by a dt. Now put x is equal to 0, then you will get f of x is equal to a, because f of x is what? A minus modulus x. So at x is equal to 0, modulus x is equal to again 0. So f of x becomes a. You substitute that value for f of x, rearrange, and then you will get this answer, that pi is equal to integral minus infinity to plus infinity sine t by t whole square dt. Now sine is odd function, t is an odd function. Odd by odd is always even function. Now even square, that is even into even, is again even function. So I can say that sine t by t whole square is an even function. So we can write that integral minus infinity to plus infinity can be changed into 2 times integral 0 to infinity. So rearranging, we will get integral 0 to infinity sine t by t whole square dt is equal to pi by 2, and hence the answer. So one of the student has requested to discuss this problem, so I thought to share with you. Thank you all for patiently listening. Thank you.